incredible. You look at these descriptions and then you realize what is actually expecting us. And in this case, I can say that I'm super excited because one of the two topics, and that is why I'm especially critical about this is one of my expert areas. We will make a comparison between CAM and additive manufacturing. And I really like this title that was chosen, Competitors or a Synergistic Partnership. And I'm very excited for this presentation. And I hope that will be the partnership part of this question, which is why let me welcome Simon Sommer. He's the head of sales at SolidCAM, and Christian Franco Romero, technical sales engineer of SolidCAM. Thank you very much. Hello, thank you for having us. Can you hear us? Okay, perfect. Right, thank you very much for the introduction. As you already said, CAM compared with additive. Are they competitors? Are they a perfect team? We've been introduced already. Simon, can you tell us something about SolidCAM? Thank you, Christian. Yes, of course. Who is SolidCAM? What do we do? Where are we? Our goal is to be in the entire world where machining is done. We want to be the perfect contact person for machining, and that is why we are present in many languages and in a lot of software globally. We have 350 employees globally, and we are steadily growing. What is our German situation? This is probably of interest for you. In Germany, within 2 or 3 hours, we can be at any of our clients in order to be the perfect contact person for CNC machining and the computer-aided machining. What's special about us is that in our technology centers, we have machines in order to help the people and show them what our software can do and what the printers can do in order to come up with the processes together with them. At SolidCAM Additive, we have production locations where we have machines available to produce workpieces for our clients. Right, let's dive into our actual topic. Let's think of the task that we need to produce a valve block. Now, the question here that we posed was, what are the options for manufacturing the valve? There is the pure additive, there is the CAM manufacturing, and the combination of both, and that's what we will look at now. Right. This is our conclusion, actually, that I would like to give you now. The component can, of course, be manufactured subtractively, but also in an additive way. Now, the question here is, what's important during manufacturing? What is special about this manufacturing? What do we need to take care of? Now, let's look at the machining itself. In machining with normal machines, there are a lot of advantages. There is a high dimensional and surface quality. I can use any material that can be machined. There are no real limits. The cycle times for serial manufacturing can be calculated pretty well. I'm in known surroundings. I do have disadvantages. There's high material loss. Sometimes I need special tools. Of course, that makes costs increase. Sometimes there would be geometrical limits, especially for cooling canals, for example. Those are some of the limits. Now, we at SolidCAM, how can we influence this from the... So we understand Solid Edge or SolidCAM. That's our perspective. And for any use case, we have the fitting module. This is a Lego principle that can be adjusted according to my client's need. Now let's look at the process itself. I have a raw material, I clamp it, I rough it, I finish it, then I drill it, and there are threads that come in, and then there's the deburring at the end, and then I detach the piece That's the general process of machining. Right, so let's look at roughing specifically. How can we at SolidCAM be the right partner for our clients? When it comes to roughing, these are the modules that can be used here for our workpiece here. We use these eye machining 2D and 3D. This only exists with SolidCAM. These are roughing strategies, special roughing strategies, and they enable us to optimize tool paths for roughing so that our clients has the advantage of saving money. That's the short version. Right, so what does eye machining consist of? It consists of two things. I have a technology assistant, and the technology assistant makes sure they have the right RPMs, feed rates, in feeds, without having to concentrate on those myself, and he also takes care of the chip thickness. That needs to be the same, always the same. Then this looks at wrap angles, and the toolpath generator makes sure that all of the toolpaths are planned optimally. What are the goals of eye machining? Of course, we want to help our clients save money. We want shorter cycle times, work times. We want longer tool use times in order to save costs again. And we want to offer a very simple handling of the whole thing. So I have this tool that controls the cutting process generally in combination with the choice of tool. This can save a lot of money. In a nutshell, that means it's very user-friendly. I can choose my geometry, I can choose my tool, I can choose the layers for 2D machining and 3D eye machining. The program chooses the layers as well, and then the tool paths are calculated automatically. There are three basic types of tool paths. We go into the helix, then we have the D paths, that's similar to a trochoid, and if that doesn't work, we go to the morphing spiral. Why do we do this? What is the advantage? If a conventional workpiece is in this working process of 30 minutes and we can reduce that down to a couple of minutes, that is our advantage. This is our way of showing to our clients that you can save cycle times and money and the machine and increase the machine utilization. And that is also very important for us to invite our clients to look at this and sit down together and calculate how can we improve their processes. Right. Now let's look at deburring. Often this is done manually with our clients. We don't really understand why. Of course, sometimes there are cases where the machine cannot do that, but in 90% of the cases, deburring doesn't need to be done by hand. We have come up with the edge breaking module for that, a module that I can add to the system if I need it. What is that exactly? It is a it comes with automatic geometry detection. It monitors the collisions, and we use different tool axes in order to break the edges with an according tool. In summary, all of the edges are detected automatically. The system does that for me, and I can then deburr these edges, and I don't need to do that manually. The machine does that automatically, and that increases the utilization of the machine. Now, what else can I do with this? Through constant depth and over the constant width, I can define phases and the size of the phase. And this is about breaking the edge so that the edge is not sharp anymore.
Das wäre jetzt mein Part.
Right, I think this is my
Ja,
part.
alles gut. Wenn wir gerade mal vielleicht die Plätze wechseln, wäre
Ja,
super.
klar.
Dann kann ich da besser
Right,
drauf.
let's switch
Ähm,
sides here so
genau.
I have a better
Jetzt
view.
die zweite
Right,
Fertigungsmöglichkeit, die
the
rein additive Fertigung,
second
Auch hier
version,
unsere,
that's the
Vor- und Nachteile.
pure
ja,
additive
das
process. This
Vorteil
comes
hat
with
dabei,
advantages and disadvantages.
Subtraktive Fertigung war
This
so ein
comes
relativ
with for
großer
subtractive
Klotz, ja.
manufacturing, that was
Da
a
können wir halt
big
schon,
workpiece.
mit komplexen Geometrien,
Here we can work with
Freifläche,
complex
Inselkanäle oder
geometries
eben auch
for
gute
cooling
Strukturen.
canals
Das
or
macht halt
grid
einfach
structures
effizienter und
as
leichter
well.
Aufbau,
There's more
ja.
efficient and a
Was mit Physik
lighter
man
clamping
weniger
of the
Material
workpiece. We
verwendet,
have less
beziehungsweise da werden nur
material
das verwendet,
use.
was man wirklich
We
braucht.
use
Man muss
only
keine
what we
Späne mehr, sag ich
need.
jetzt mal, noch entsorgen.
No chippings need to be
Man
gotten
kann
rid
also
of.
relativ schnell, ohne
There's
irgendwelche Maschinenkapazitäten,
without using a lot of
belegen
machine
oder extra
capacity
Werkzeuge,
or
sich
coming up
besorgen,
with
sondern
extra
Werkzeuge,
tools.
schnelles
We
Prototyping machen,
can
mit
do
schnellen
quick
oder,
prototyping
schnell Iterationsschritte,
with quick
Verbesserungs-
integrating
Verbesserungen in der
steps
Konstruktion quasi,
for
erreichen.
improving the construction
Nachteil
process. What is a
natürlich,
disadvantage here? Of course,
beziehungsweise reines Wunschdenken, dass man mit reiner
this is
Additive
wishful
quasi einfach nur
thinking
Copy-Paste
that
und einfach
pure
nur druckt und hat man
additive
ein fertiges
means
Bauteil,
copy-paste. They
weil
simply print something
diese
and then have a
hunderttausendsten
beautiful
3D-Druck,
workpiece, because
bekommt man
these
einfach nicht hin. Ja, deswegen
hundreds
ist
and
die
thousands parts in
Nachbearbeitung,
3D
was man für Toleranz
print, they of
sehr, sehr
course
wichtig, ja.
always take mechanical
auch
post-working,
wieder
post-processing.
Metallherstellung
In
oder für Metall,
in
je
3D
nachdem,
printing for
welches
metal,
Verfahren ich
depending
natürlich
on
verwende,
the
das
printing
passende Material, ja, oder man
system,
muss halt relativ viel R&D
there
auch,
is
reinstecken.
fitting material and R&D
je
resources
nachdem
needs to be
auch,
spent for this.
welches Druckverfahren oder
And depending on the printing process and depending on this, the size of the workpiece also needs to fit. Right here, you can see an overview of the technologies, and what we see also here at EMO is that the knowledge, the expertise is missing. Often people do not know of their opportunities in 3D printing for metal. We came up with a study. We used a normal FDM print, but it cannot print metal, and many people know. And it was a metal printing device, sorry. And many people think, oh yeah, I know that from plastic printing, and they simply often don't know that these can be used for metal printing as well. And they don't know how to adapt their products to this. Also, here you can see the technologies and the processes that are available, and there's many abbreviations, and there's so many advantages and disadvantages, pros and cons to these. And to know them and apply them to one's own products, that's very hard. And that's where we come in. We do the consulting. We talk to our clients and tell them, you have that problem, you have that product. Maybe here you can be more efficient, and then we find a solution. For our workpiece, we concentrated now on the binder jetting process. That is a machine that we have in our production site. Here's a short video of how that works. The most common process is that I have a powder and I have a laser that goes up and down my tool path. But there's also the binder jetting process with a powder, but instead of a laser, I have a 2D printing head, like in my inkjet printer at home, and then a binding agent is applied wherever the powder meets the workpiece. The result are green bodies that, in order for them to be stable in the end, they need to be sintered, and this is added to in our process. The sintering technology is another thing that needs to be understood, and it needs to be integrated into the processes and into the production.
So, jetzt hier.
Right, this is the combination of the two. If you looked at the picture of the pure additive workpiece with the bearings, with the holes, But what we did here is we filled them up. So we printed something on top. Through a conventional manufacturing process, we came up with the final workpiece here. And that takes us to our goal together. So we link the two advantages from the two technologies and make something great from it. Yes, exactly. You said it. What we do is we look at the advantage of the one technology and the advantage of the other one, and then we try to combine them. So we don't say that machining will die because additive is the best version. We are convinced that both are important. This doesn't work for every type of component or workpiece. This is an individually assessed thing. But please tell me now, what is the biggest challenge you see with this? Well, here's a short overview. The topic is not only about printing workpiece. What we see is first, many people are resistant to consulting, to hints and tips. They've been doing things for 40 years. They want to change. They don't want to change anything. So it would be very important as a business person to be open to something new and to go down that route and find out what's happened. That, I think, would be a first step. Of course, this comes with, of course, this is also due to a lack of knowledge, of information. Oftentimes, people don't know about the opportunities of 3D printing for metal. But they also don't know about the combination. They don't know that through a combination of these two, you can come up with great products, you can optimize products, and you get added value. If these two things were to be successfully implemented, we wouldn't have so many problems in reverse engineering for replacement, for the replacement business. We need to start in construction and come up with the processes accordingly. Right, it's interesting that you mentioned this. We need to be open, we need to broaden our horizons, and we need to look into new processes. And in machining, this is what we've been experiencing over the past years. Often it's CAM systems for milling, there's a CAM system, and for milling and turning systems there would be another CAM system, and we think that is a little bit problematic because it is not uniform, that one department doesn't know what the other department is doing. They think their system is the best, and oftentimes they're not even able to help each other. Departments should be cross-departmental. They should be able to help each other, to work together, to replace each other, to be proxies for each other. I feel like this is also an approach to attracting the next generation. Right, we would like to provide a holistic solution, and our dream from a SolidCAM perspective, of course, is to come up for the milling, for the turn milling arena. We came up with one solution for all of the problems. So we tell our clients, you can use the system for all of your processes. All of your departments can train each other. There's unified support, and it is future-proof. Right. As I said, it's future-proof. It is one software, one solution for the entire manufacturing process. And this is where our colleagues from the additive world come in. Of course, when it comes to the future, this is what we imagine the manufacturing to be like in the future. For every manufacturing, any type of manufacturing, there needs to be a 3D print solution as a synergy, as a completion, not as a replacement. The two needs to go hand in hand, or need to go hand in hand. The components need to go hand in hand. So as a summary, again, whenever it's possible, try to broaden your horizon, take a look outside the box. Is this a component that I can maybe optimize if I print it in the first place, or where I can change it constructively together with my client maybe, because it makes so much more sense these days to save material, to save weight, to change the component in a constructive way in order to come up with a holistic way of manufacturing it. Yes, because it's always about making materials and to use material and to slim down processes. But there's other problems. Value chain, for example. I had an appointment today with a client asking me whether they could actually 3D print that product so that they would save time. Yes, and I said, yes, that's possible. Or to get rid of capacity peaks, to save time, to save material for machining components that need to be machined, tool wear, tool costs. Those are things that need to be taken into account here. Because oftentimes the investment for the 3D printing is seen, and people don't want to put in manpower, and people don't want to teach new employees. But yeah, we need a holistic approach here. Okay, great. For us, you need to keep developing, we need to keep developing, and that is why we are not on our own. That is why we have technology partners for the CAM, for additive. That is the way, together with our partners, to come up with new things, to optimize processes, our post-processors that are needed in order to translate the software onto a machine. Those are the things that we keep working on, together with the machine tool manufacturers that we cooperate closely with. Right, so these are only a few of our partners. Many of those you will probably know. At SolidCAM, when it comes to 3D printing, we also work together with a lot of schools, because that's where we need to start. The decision makers of tomorrow, those are the ones that we need to take on board now, because if they then go out there, they need to be able to integrate 3D printing. Okay, perfect. We would be delighted if, together with some of you, maybe we could shape your future of manufacturing, or our future of manufacturing. We keep learning with every new project, and that is why we would be delighted if some of you would actually approach us, tell us your story, tell us your challenge, and then we would love to help you. Hall 6. Booth B46, please come and see us. We'd be happy to see you. Okay, I would like to congratulate you first. That was great. I thought it was amazing. Let's talk about some questions. I would probably not have asked this question, but I would have thought the audience would come up with this question, so let's talk about it. Is there a cost comparison between additive, subtractive, and combined? We saw all of the three options. What are the costs? Right, let me put it like this. I would have wished for that, but I didn't have enough time for that. There are many factors that come in here. As I mentioned, machine hours, tools, and so on. I think we'd have to calculate that afterwards, after this, but I would say the most cost-effective, or does it need to be the most cost-effective? Is it maybe enough if the supply chain can be shortened down? So it depends on the application, really. There are individual prices. I need to add that we chose a workpiece here that we would have to go into more detail on with a partner. We do this in workshop together with SolidCAM and with additives. We often work on these workpieces, and then we come up with this data as reference. We, of course, went through a lot of clients' projects where this data, where we where data was already available, batch size, the amount of the volume. So we cannot really give a general answer to which one is always the cheapest one. Well, I'm from additive manufacturing, which is why I can help you. I can give you the response. The response is it depends. The question is always, what is the workpiece then used for? You presented that beautifully with additive. I can do a lot more than traditionally would, but it comes with a lot of disadvantages, as you said, so there cannot be a general statement here. It always depends on the use case. And yeah, I thought that was great that you showed us the parallel worlds here, because at the end of the day, that's what this is about. You cannot consider one or the other as the absolute technology. The combination is the good thing, and thank you very much for presenting this to us. And from my perspective, and then I will stop praising you. No, this was really great for me personally. You are manufacturers of these workpieces, and you are the people who are great for presenting this to us. Thank you very much. Sensational presentation. Thank you. I wish you a lot of success at SolidCAM. It was great to have you. Ladies and gentlemen, give them a big hand. Thank you very much for your time.